Right, welcome to lesson 3 of unit 7. So we're making progress, we're almost halfway through. The big idea here is that when in doubt, whenever you're given an equation like this, if possible, you want to make a common base. So that is going to be the theme for the entire lesson. So just bear that in mind. Common base, common base, common base. So when we look at these examples, that's the first thing we're going to look for is working with a common base, and then we're going to start looking at our exponent laws. So if you need a quick refresher, I'll post a video link to that so you can kind of go over what are all my exponent laws, because those are going to be really important here also. So common base is step 1, exponent laws step 2. And from there, also just kind of like algebra is going to be your third step. So that part should be the easiest. Once we get past those first two, it should be relatively smooth sailing, just always watching out for those integers. So in general, we should probably know that an exponential equation is one that we have a power and the variable is in the exponent. So as opposed to having the denominator being a variable, which is what we've been used to working with since we started having powers in algebra, we've switched it up and now we've got that variable in the exponent. So like I said, 3 steps: common base, exponent laws, and algebra. So let's begin. With this first one, 16 and 32, there's no way that 16 can be like squared to 32. So I'm going to go with the common base that I know goes into both of these quite nicely, which is 2. So I'm going to rewrite 16 as 2 to the power of 4. And then leave my exponent on the outside, equals, and 32 is 2 to the power of 5, x plus 3. So now that I have a common base of 2, I can use my exponent laws to simplify what's going on here. Now a power of a power means multiplication. So what I'm going to do is I'm going to distribute this 4 out, and I'm going to distribute this 5 out to both terms of the binomial that's in my exponent. So I've got 2 to the power of 8x minus 12 equals 2 to the power of 5x plus 15. Once I've done this, because the bases are the same, the exponents would have to be the same in order for this whole statement to be equal. So what I can do is I can assume that the exponents are equal, and I'm going to drop my bases because I'm a DJ secretly. You didn't know that about me, did you? I'm just kidding. Okay, and I'm going to just look at the exponents. And from here, this is where the algebra comes in, collecting like terms, isolating your variable. I get 3x equals 27 and x equals 9. And then I'm done. Solve the equation. There's no restrictions on what I can have in my exponents because as we've seen in our previous lessons, we've got no restrictions on our domain. So I don't even need to like go back and check. You can if you want, just to be sure. If you want that peace of mind, go ahead. But I can feel pretty confident that this is not a non-permissible value because I don't have non-permissible values. Moving down to B. I've got 4 to the power of x, and then I've got 256. So you may not recognize that one right away. You may want to just go straight to 2 to the power of something, and that's quite possible. If I'm not mistaken, this is to the power of 4. If you want to use your calculator here, that's not a bad idea. You can bust it out and figure out, okay, 4 to the power of what gets me 256. So noting that it's in the denominator means that my exponent is going to have to be negative. So it's 4 to the power of negative. And if I use my calculator and divide 4 into this, that goes in 4 times. And so that is going to be my next statement. That because I have my common base now and there's no extra algebra, I can restate this as x equals negative 4. And that's actually my final answer. So that one's kind of nice and simple. Scariest part is the fact that 256 might not be perfect that you are familiar with. 27 and 9 automatically sings the idea of 3 to the power of 3x equals 3 squared to the power of 2x minus 1. Again, we can use our exponent laws here, and we end up with 3x equals 4x minus 2, and I've just skipped the step where I write it in as my exponent. I've skipped the step. I've automatically eliminated my base here. Once I've got this, same as before, I'm going to get x equals 2. And again, you can totally plug this in and check. So if I go 27 to the power of 2, that should equal 9 to the power of 2 times 2 minus 1. Then you can use your calculator to evaluate that. So that's how we evaluate equations like those ones. When we have radicals, the key thing to remember is that a radical means a fractional exponent. So when I'm looking at this one, I've got 2 to the power of x equals, I'm going to rewrite 8 as a power of 2 as well, 2 to the power of 3, but then this part, my radical, becomes 2 to the power of a third. So again, that number attached to my radical, the index is what it's called, the index is my denominator. Of my exponent. So I'm going to, when I'm multiplying with a common base, I add my exponents. So I've got 2 to the x equals 2 to the power of 3 plus a third, so it's 10 thirds. So x equals 10 thirds. I'm okay with that. Okay, coming over here, again, might be a little bit trickier. You might notice that this is power of 5, so we might be working with 5s. So common base, I've got 5 power of 3, big 2x plus 1, and then under the cube root, and I'd figure out this is 5 to 4. Okay, and I'm going to keep simplifying and getting rid of those radicals here. So 5 to the 3 to the 1/2, the power of 2x plus 1 equals 5 to the 4 times the third. So I might multiply this half through first and then do the 3. I might go 3 halves and then multiply that through. Whatever your process is, we're going to have to be multiplying all of these exponents together. So that leaves me with 3x plus 3 halves equals 4 thirds. From here, this is not exactly a pretty question. 3x equals, and I'm going to subtract a half from 3 halves from over here. Okay, which means I'm working with fractions, and I'll go from there. The end game still being that I want to figure out what x equals. So implying that I need a common denominator, I get -1/6 equals 3x, and so then by dividing by 3, I end up with -1/18. So it's not necessarily a pretty number, but it is a number. Again, you can always check by plugging back in and verifying. So here, at least on the right-hand side, we have a value, so that's something nice to work with. And it also gives us a clue as to what base we're going for, because we want to go for the smallest one available. So in this case, it's going to be 3. So I'm going to rewrite this as 3 to the power of 4 to the power of 3n plus 2 divided by 3 to the power of 5 to the power of -n equals 3 to the 4. From here, I'm going to use a lot of exponent laws, and I'll do them step by step just so you can follow along. I'm going to do my distribution through here. And again, that's multiplying. So I've got 3 to the 12n plus 8, that's not divided by 3 to the power of negative 5n equals 3 to the 4. And I can even simplify this further. When I'm dividing with a common base, I can subtract my exponents. So I'm going to be left with 3, and subtracting a negative is like adding a positive, so it's going to be 17n plus 8 equals 3 to the power of 4. 17n plus 8 must equal 4 in order for this to be true. So we've got 17n equals negative 4, n equals negative 4/17, and I would leave it as a fraction. So again, not necessarily the prettiest of numbers, but in any case, it is a number that we can work with. So again, you can plug this back in and use a calculator to verify that this isn't true, or you can trust me. So I know I've made some mistakes in these most recent videos because we've been trying to get them up quick, so you might want to double check that one or check my math going through here. So if you have any questions on this, otherwise, again, I will be posting homework to go along with this to practice the idea of kind of simplifying to a common base using our exponent laws and then using algebra to solve for these variables.